Hey guys, Dr. Callahan here. Welcome to week 4, Thursday. Go ahead and pause the video to answer the following questions for your warm-up. And as you know, Rib Cook-Off obviously was canceled, so that's really unfortunate and sad. All right, here are your answers for number 2. You should recognize that the numerator is a cube factorization. Of course, your positive 3 and negative 3 cancel, so you're left just that factor of x. And then x in the numerator and denominator cancels each other, so that right here eliminates the 0 when you use direct substitution. And once you plug in the 0, you should have 27 as your answer. All right, so when you're in pre-calculus and trig, these are the 11 things that you should have talked about in those classes. And as you can see, factorizations of cube is one of those requirements. So last time I saw you guys, we did a foldable on this, and there were 8 questions on there. So these are the 8 questions. Let's go ahead and go over the answers very quickly. And I can go over a few of these questions with you in class. Here is one of the questions that we actually did as a warm-up. Here's question number 3. For question number 3, you should see this as we are going to go ahead and get rid of this using the conjugate. So let's go ahead and multiply by 5 plus the square root of x, 5 plus the square root of x. And when I go ahead and do that, you will have to FOIL the numerator, which is going to give you a 25. Your inner and outer cancel, so your last is going to be a negative x. And over here in the denominator, you're just going to go ahead and keep it as is and not FOIL it. And the reason for that is because if you look at the numerator and the denominator, you can see that you can directly cancel them. And if you were to FOIL the denominator, it will probably be a little bit more obscured. 25x minus 1, or 25 minus x cancels. You're left with a 1. Now let's try the direct substitution of 25, which is going to give you a 1 over 5 plus the square root of 25 is a 5. So 1 over 10 is the answer. Here's question number 4. Question number 5. Let's take a look at question number 6. With number 6, you can see that if you use direct substitution, you are going to result in a 0 because 5 times 25 minus 50 plus 25 is going to give you a 0. So direct substitution does not work, unfortunately. But you can factor by trinomials here. And if you look at the numerator right here, the way that you factor this is you're going to have an x and an x. And you want to know what times what gives you a negative 35, which is your last number. But the same 2 numbers added together have to give you the middle number, which is going to be 2. So if you think about it, I think 7 times 5 is 35. But I might have to go ahead and change the signs a little bit so I meet the criteria. And given the fact that it needs to be a positive 2, I know it's going to be a positive 7 and a negative 5. And it does meet the criteria. So x plus 7, x minus 5. Do the same thing in the denominator over here. What times what give you the last number, which is 25. And the same 2 numbers, when you add it together, give you the middle number, which is a negative 10. So the first thing that comes to mind is I know 5 times 5 is 25. But then once again, you have to change the signs a little bit to meet the criteria of getting a negative 10. So maybe a negative 5 times a negative 5. Or a negative 5 plus a negative 5. So in the denominator, I know that it is going to be xx minus 5 and minus 5. And looking at this, you can see that you can cancel one of the numerator and denominator of x minus 5. And so then after that, I am going to have x plus 7 over x minus 5. And then I'm going to try my limit again as the limit approaches 5. And once again, I am stuck in a situation when I have a 0 in the denominator. So in which case, there's nothing I can do algebraically to go ahead and simplify it any further. In this situation, it really is going to be undefined. I would highly recommend that to check this, you can also graph it. And if you do graph it, you will be able to see that it is undefined. Or you can also try the table method and have x approach close to 5 on the left side, so we'll do a 4.99, and then x approach 5 on the right side, so 5.01, and you will be able to see that it is indeed undefined. In some case, you're going to have questions that's just undefined. Here is question number 7. And if you need some additional practices, I do have 10 more questions right here. And here are the answers to those 10 questions. All right, so let's go ahead and continue. So today we are going to talk about an intuitive understanding of the limit process, which is going to include continuous limits, discontinuous limits, and I'm going to go over 2 different types. And they are Dom continuity and removable discontinuity. And that's my little girl wanting an apple. Here you go. No, you don't want the apple? Would you like to have the green apple instead of the red apple? Okay, would you like to have a piece of bread? Sorry about that. Here, take the bread. All right, I'm gonna have you guys do a little bit of a discontinuous calculus puzzle, and it responds to a question: what did the asymptote say to the removable discontinuity? We'll check the answer at the end. I have 6 questions on graphical limits. I'm gonna have you guys do on your desk, and then if we have time, we also have a quizzes practice. Okay. Let's go ahead and take a look at your guided notes for today. So your notes look like this. These are the 6 questions you're gonna be practicing on your desk. This is my notes for the class. This is your calculus puzzle on the left side. This is my notes typed up for you guys, so you don't have to type it. You might want to go ahead and read this first beforehand. It's 2 pages. All right, let's go ahead and get started with today's stuff. What does it mean to be continuous? A function f of x is to be continuous at x equals a if the limit as x approaches a, f of x equals f of a. A function is said to be continuous on the interval a, b if it is continuous at each point in the interval, meaning that there isn't any breaks. So if f of x is continuous as x equals a, then the following 3 parts are met. Or the following 3 parts are satisfied. As x approaches a, f of x equals f of a. Second one is as x is approaching a from the left side, f of x equals f of a. And as a limit, x is approaching a to the right side, f of x equals a. So let's take a look at this right here, okay? Here is a. If I am approaching on the left side of this, it looks like y is 3. Okay, so y equals 3. If I'm approaching a on the right side, it looks like y equals 3 as well. And then simultaneously, as x is equal to a, which is right here, y is equal to 3. And because in all 3 of these scenarios, as I'm approaching from the left side, right side, and when it's exactly at a, all 3 of my f of x's is equal to f of a, which is 3. And because it's consistent and there's no break in this line, I can say that this limit is indeed continuous. But you would have to check all 3 in order to make that determination. Why are these limits discontinuous? So you have 3 different scenarios. And the reason for that is, if you look at the first one, as I am approaching to the left side, it is, let's say, at 4, okay? I'm approaching the left side, y value is 4. As I'm approaching on the right side, still continuous, it's still 4. However, if I look at exactly as x is equal to c, it's empty. So unfortunately, all 3 conditions are not met, so it's not defined. Let's take a look at the second scenario in the middle. As I am approaching to the left side, my answer is right here. As I'm approaching to the right side, unfortunately, my answer for y value dips down. And then when x is equals c, it is the same answer as when I'm approaching from the left side. But because all 3 conditions are not consistent, it does not exist. It's not continuous. And the very last one, as I'm approaching the left side, I have an answer right here. As I'm approaching the right side, it's continuous so far, and it is consistent. But then when x is equal to c, it goes all the way down to the bottom. And so all 3 conditions are not met, therefore it is not equal. Okay, what I want you guys to do right here is take a look at this example, and I want you to tell me if it's continuous at x equals -2, x equals 0, and x equals 3. So pause the video. Okay, go ahead and take a look at the answers here. When x equals -2, so as I'm approaching the 2, when x is equal to 2, you can see that the y value is at 2. As x is approaching to -2 on the left side, it is also equal to 2. However, as x is approaching -2 on the right side, you see how it dips down to -1. So it's not continuous because all 3 conditions are not met. X equals 0. As x approaches 0 on the left side, the answer is 1. As x is approaching 0 on the right side, it's still at 1. And when x is equal to 0, it is 1. Since all 3 of those conditions are met, you can say that the limit exists at 1. When x equals 3, as I'm approaching x on the left side, it is at 0. As I'm approaching x on the right side, as I'm approaching 3 on the right side, it is also at 0. But when x equals 3, it is at -1. So all 3 conditions are not met, so this one does not exist. And here's another way that you can see it. It's the same question with a better explanation because it's typed out. And also take a look at when x equals 3. This is called a removable discontinuity because you are essentially moving the x equals 3 to the bottom. Okay, example 2, determine whether the function below is not continuous. So you have h of t equals 4t plus 10 over t squared minus 2t minus 15. So what do? You want to set the denominator to 0, factor the denominator, solve for t, and basically the way you answer this is you say the f of x is not continuous at t equals whatever t is equal that will make the denominator equal to 0, which will be undefined. So in this case, if I were to factor the denominator, what times what gives me a -15? But when I add it together, it gives me a -2, -5, and +3. So when I solve for at t, I will have -3 and +5. So I will say, so the function will not be continuous at t equals -3 and t equals +5. Okay, let's take a look at this one. Look at the 3 different graphs. Does the limit f of x at x equals a exist? What is your reasoning? Pause the video and take a look at this. Okay, if you take a look at this, rule number 1, f of x is not defined and f of a is correct because when x equals a, it's not defined. It's empty, okay? So that's a violation of the 3 rules. Second one, rule 3, f of a is not the same as when you're approaching from the left into the right. As I'm approaching to the left, it is the same as when I'm approaching to the right. However, when x equals a, it is not the same. The last one, it is indeed continuous. As I'm approaching to the left, it's the same as when I'm approaching to the right, and it's the same when x is equal to a. So it is continuous. Okay, at this point, on your desk, there are 5 questions that I would like you to go ahead and attempt to do. When you are done with that, you can go ahead and continue on. What did the asymptote say to the removal discontinuity? Answers are given to you right here, and you just put in your puzzle on the bottom, or fill in the puzzle on the bottom. If you ever need to check your answer, I do have a document right here. You just then type it in, capital T, capital L, capital A, capital K, A, capital R, or E, lowercase r. And actually, this is the answer to the puzzle, so you can check it yourself. And that is it. I hope you guys have a wonderful day. I'll see you guys next time.